So today we're going to continue what we have done in the previous video. So in the previous video we show how to prove this theorem. So today we want to try to prove that the angle y, to prove that BPC is equal to BPC equal to BMP, which is equal to y. So we have to prove. So what are we going to do here? As we say yesterday, to prove we say in a previous video, to prove what we call Tan-Chord theorem, you have to look at this angle, okay? You look at this angle should be equal to this. But how to make it possible? You have to draw a diagram. That is the method to do it. Draw a diagram, a diameter, sorry. You draw a diameter. You draw a diameter. Okay, this is a diameter. This is a diameter. Okay. There we go. This is a diameter. Then we move over here. Okay. If we move over there, because we are looking for M, he's not going to work. Okay. So here you cannot come this side to join this point to M. No. You have now to move this side of a B. Alright, because the chord is BP. So we use the chord BP. We're not using the chord PM. So you take this side, alright? There we go. And then we have this point, we can call it A. So now what we're going to do, we have to write it down, draw what we did, draw a diameter, we can just say draw, sorry, alright. So we draw a diameter PAP, or the diameter PA. Okay. After we draw the diameter PA, and then we join AB. We join the line AB. After we join this line, what we're gonna do now? This is how we do it. We say angle B, it's 90 degrees. Angle, reason because the angle of a semicircle. So once we have that angle of a semicircle, this is the angle of a semicircle. Now, this angle is what? 90 degrees. So radius, it's a perpendicular, tangent is perpendicular to the radius. So this angle, all this, it's 90 degrees. So the small angle here will be 90 minus y. So if all total here is 90 degrees, so this is y. So here will be 90 minus y. So because if we have a 90, because these two angles should give you 90 degrees. So 90 minus y plus y will give us 90 degrees. Okay. So we stop there. Now we say the angle, that is the angle A P to B. So this angle, this is how we see the angle APB. That will be 90 minus y. The reason is tan and the radius, tangent and the radius. Okay, it's perpendicular, tangent and the radius. So tangent is perpendicular to the radius. So meaning that if this is 90 degrees, this is 90 minus y, automatically this will be y. Because if we take the angle B, 90 degrees, the angle A, it's y, and this angle is 90 minus y, so this will be cancelled. So the angle is 180 degrees. So what do we do here? We know that the angle A is equal to y. The reason is sum of the angle in a triangle will give us this. Alright. So now once we have that, we can see obvious now. A is equal to M. A is equal to M. What is the reason? Angle of the same segment. Okay? Same what? Segment. Now, once we have an angle of the same segment, what is going to happen now? Angle of the same segment. Once we have an angle of the same segment, so we can find that M is equal to Y. Now look at this is equal to Y, okay? So now we found that M is equal to Y. Alright, what is M? It's B. MP is equal to Y. So we got it. Alright, so we come to the conclusion. So the angle BPC equal to the angle BMP. So we prove this question. So now let us move to the next question. The next question, we're gonna move to the next question, which will be very simple. The next question, we want now to practice, okay? Now I want us to practice this question, okay? When you look at this question, there's something I want you to look at here. We need to practice. We learn a Tan-Chord theorem, okay? So when you look at this question, you find that the tangent we have is KT, okay? That is the tangent. And the chord that we have, they say it's what? The two chord here. Okay, there is another chord which is a parallel. So it's very important for you to look at or to read or to understand your graph or your diagram, okay? So the diagram that is given, this is a tangent, okay? This is a chord, this is another chord, this is a chord that form a Tan-Chord theorem, as we say. Once you have a tangent, you have a chord, this, they join each other. So this is a chord, Tan-Chord theorem. So now, what the meaning of these two signs? Meaning that KT is parallel to NM. So now, when it's parallel, let's try what that means. When you have a two line parallel like this, okay, and then you have a form of Z. Remember, if I do this, the total here is 180 degrees, okay? And this is a straight line, it's 180 degrees. So for example, if this is 50 degrees, what will happen here? This will be 130. This is example. So meaning that when you have something like this, you have this, okay? Something like this. If these two lines are parallel, these two lines are parallel, these two, when you add them, should give you 180. Meaning that if this is 50 degrees, this will be 130. Meaning that this will be 50 degrees. So the angle of a parallel, when you have these two angles, they should be what? Equal. So in our question here, what we know here, automatically we see this is a parallel line, this is a parallel, and this point join over K, join M, which is another parallel. So they form what we call Z. Can you see? Meaning that the angle K1 plus K2 is equal to this angle M1. So this angle and these two angles are equal. Can you see that? Very good. So we will say the angle, we know that the angle MK, the angle KT will be equal to the angle M1. So M1 is equal to 84 degrees. What is the reason? Same angle of the same what? Parallel. All right. Angle of the same what? Parallel. Now, as we have an angle of the same parallel, so here we write 84 degrees. So it's better to write it already. Next, what will happen? They can ask us to find the other angles who are equal to 84. Which any other angle is equal to 84? Now we look at from this point K, we move to M, and we move to N, we move to L, we go back to K. So these two angles are equal. Why? Because they are angle of the same segment. You see, there is a segment here, this segment starting from here. So these two angles are equal. So we say that the angle again L2 is equal to 84 degrees because what? Same segment. Same segment. Angle of same what? Segment. All right. So, which means we can write here 84 degrees. Can you see? So now, if we have that one, 84, we have to look at another angle. We can try, if it's possible, to look at which other angle is going to be 84. Is it possible? Let's check. Now let's go to tangent, okay? We have a tangent, remember? So for the tangent, the angle which is this one, K2, angle of a tangent, tangent theorem, it says K2 should be equal to this angle, not this one. Remember, we have chord, so this angle, if we do this, we have a tangent we have this chord, we have a chord there. So this angle should not be equal to this, because the same line, not this one, but should be this angle in the right side. So which means this angle K2 is equal to 40. K2 is equal to 40 degrees. Reason is Tan-Chord Theorem, okay? Because of a tangent and what? Chord. So these two angles are equal. So if that is K2 is equal to 40, so what will be K1? Alright. K1 will be automatically 44 degrees. Why? Because we have a K, the total of the angle MKL is 84. So meaning that K1 plus K2 should give you 84. So if K2 is 40, K1 should be 44. Okay. So here we just say we can leave it like that. That is obvious. Okay. Now look at now, if this is 40, this angle K1 is 44. So what will be this angle? Can you see? What will be this angle? We look at the triangle. There is this triangle here. Can you see this triangle? Okay. If we can name this angle maybe Z, let's call it Z1 and Z2. So this angle automatically will be what? Because we have 84, 44. So Z1 will be equal to 180, because the sum of the triangle, the sum of the angle in a triangle gives us 180, because we look at this triangle, okay? Let's look at this triangle, because this is 44, this is 84. So the sum of the angles should be 180. So we have 180 minus 84 minus 44. So this angle will give us 52. So now we say angle Z1 will give us what? 52 degrees. What is the reason? Is the sum of angle in a triangle. Okay, now what will be the angle Z? We look at again this. And look at all this. Can you see? So you can find all this angle just by trying to work here. You find all this angle. Okay. So we can even find the angle T without going there. I will show you the method. Okay. If we leave that one, we can just say, okay, what is this angle? What is the angle? Let's leave this one. Okay, let's forget about Z, because it was not there. Let's leave it. Let's look at the L3. What is L3? Because the angle of a straight line, can you see here there is a straight line? So all this angle is 180. So we have 180 minus 84. So this angle is 96 degrees. We say angle of what? Straight line. Alright, now let's look at this angle T. What will be the angle T now? Because this is 96 degrees. Here we have what? K2. We have 40 degrees. So what will be the angle T? Sum of the angle in a triangle. So we minus this by 40. we minus by 40. So this angle T will be equal to 56 degrees. Reason why also sum of angles, sum of an angle in a triangle, the total will give us 180. So we have a sum of of an angle in a triangle. Okay, so if this is 40, 96, so this will give us 56. So we add. Okay, so we say the total should give us 180. So we say 180 minus 40 degrees minus 96. So this will give us 96 will give us 44. So here not 56. Our calculation was wrong. So this gives us a 44 degrees. All right, 44 degrees, which is this angle and this angle are equal. So K1 is equal to the angle T. So now if we want to find the angle N1, look at also this is the same segment. If we do this, we say K, we start from N, L, K, M, we go back. So this angle should be equal to this one. Same segment. So we say again, angle N1 is equal to the angle K1, which is equal to 44 degrees angle of the same segment. So we can continue to find the L1. Try L1 yourself. That will be very good. Thank you.